Our task is to write the truth table of the logical statement, not P or Q. The truth table that we are going to construct will have the number of rows determined by this formula. We'll have 2 to the power of n, where n is the number of propositions identified. Since we have only 2, that's P and Q, so we'll have here 2 squared, which is equal to 4. As mentioned, this determines the number of rows for our truth table. Now this excludes the header. The first part of our header would include the propositions themselves, P and Q. And after that, we will come up with the number of rows for each. So we have 1, 2, 3, and we have here 4. This would be our truth table. Or if you would like to, you could extend it here, adding one more row but for our header. For the first two columns, we are going to place here the truth value for our propositions. It would be in this manner. For our P, we will accept true, true here, because both of this will be paired to our Q. The first one is true, and the second would be false. Now for our next two entries, for our P, we'll have false, and we have here false, and finally, you will have here true and false. You would see that all possible pairs are there, and as you can see, we have 4 rows here. The next part of our truth table will now include the first identified operator here, which is the negation of our P, or the not P. So we are going to complete this first before going to our final form, the set of results for not P or Q. So we'll have this here. So it's always nice for us to remind ourselves with different results for different logical operators. Let's start with this column. Since it only concerns with the proposition P and it follows the logical operator of negation, we are just going to reverse the truth values assigned on our first column. So since this is true, this will become false. Next, this is also true, this will become false. Next, since it is false, this will be true, and finally, for false, this will be true. This is now the column for the negation of P. But this is not yet over because the final form is for the truth values for our truth table for not P or Q. Since here we have the logical operator of disjunction, we are going to examine the truth value of the paired propositions under disjunction. We are not going to use here P, but instead we are going to use the negation of P. And take note, under disjunction, it will, or the result will only be true if at least one of the propositions, in this case, not P or the negation of P, and Q is true. At least one. Now, we are going to look into the second and the third columns as they are the columns for the negation of P and then Q. Looking at the pairs for the first row, since our Q is true regardless of our negation of P being false, together with these two, this is true. Next, for our second, since both propositions are false, this would mean that our result here will be false as well. Because for disjunction, we need at least one of the propositions to be true so that our result will also be true. Looking into the third row, we have true and true. Of course, we have two true propositions. So we have here true. And finally, for our last row, we have false and true. We have one true proposition. This is also true. With all of this, looking in our fourth column, this comprises the truth value of the logical statement, not P or Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.